Kuzuzangbola, welcome to Bhutan e-learning project. This is Sing Wangchuk, teacher of Khasarapchu Middle Secondary School. Today, I will be taking you through the properties of inverse trigonometric functions. This lesson is intended for the students of Key Stage 5, classes 11 and 12. Now, to move on with the objectives of the lesson, first, by the end of the lesson, each student should be able to state the properties of inverse trigonometric functions. Second, prove the inverse trigonometric relations using the properties. Finally, solve the inverse trigonometric equations using substitution method. Of many properties of inverse trigonometric functions, today we are going to focus only on the properties of tangent inverse and sine inverse. Firstly, we will discuss the properties of tangent inverse. Tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y divided by 1 minus x times y, if x times y is less than 1. So here, first we will have to identify the value of x and y and find the product of x, y. If the product of x and y is less than 1, then we are going to use this first property. And second property, tan inverse of x minus tan inverse of y is equal to now tan inverse of x minus y divided by 1 plus x times y, if x times y is greater than negative 1. If product of x and y is greater than negative 1, then we are going to use the second property. Now the properties of sine inverse. Sine inverse of x plus or minus sine inverse of y is equal to sine inverse of x times square root of 1 minus y square plus or minus y times square root of 1 minus x square, if x and y value is greater than 0 or equal to 0, and the sum of the squares of x and y is less than or equal to 1. Here again you will have to identify x and y value from the question, and to use this property you will have to take two conditions. First condition is you will have to look at the values of x and y. If it is greater than 0, that is positive quantity, or if x and y is equal to 0, then first condition fulfills. And then we check for the second condition, x square plus y square. And when you square x and y and add up, if you get the value less than 1 or equal to 1, then we are going to use this property. Now sine inverse of x plus or minus sine inverse of y is equal to pi minus sine inverse of x times root of 1 minus y square plus or minus y times root of 1 minus x square. If again the first condition is same, provided x and y should be greater than or equal to 0, and x square plus y square should be greater than 1. So now check again, you will have to check x and y value, and if it is greater than or equal to 0 and x square plus y square is greater than 1, then we are going to use this second property of sine inverse. Let us prove tan inverse of 1 over 4 plus tan inverse of 2 over 9 is equal to cos inverse of 2 over root 5 using tan inverse property. Here, first we will have to identify the x and y value. X here is 1 over 4 and y value here is 2 over 9. To decide which property to be used, we will have to find the product of x and y. So now xy, product of xy, 1 over 4 times 2 over 9 is equal to 2 over 36, which will be obviously less than 1. If by property it says if the product of x and y value is less than 1, then you will have to use the property tan inverse of x plus tan inverse of y equal to tan inverse of x plus y divided by 1 minus xy. Since we know that the value product of x and y is less than 1. Now we have value of x 1 over 4 and y 2 over 9. We will substitute the values of x and y in this equation or property. Now this will be equal to 10 inverse of x plus y. X value is 1 over 4 plus y value is 2 over 9 whole divided by 1 minus xy, so 1 over 4 times 2 over 9, which is equal to 10 inverse of, on simplifying this you will get 17 over 36 divided by, instead of this division symbol we can use this division symbol. So now 4 9 36, okay, 36 minus 2, 36 minus 2 divided by 36. On simplifying this you will get 10 inverse of half. Now you get 10 inverse of 1 over 4 plus 10 inverse of 2 over 9, you get 10 inverse of equal to 10 inverse of half. But here we are not asked to prove 10 inverse of 1 over 4 plus 10 inverse of 2 over 9 as 10 inverse of half, but we are asked to prove the value equal to cos inverse of 2 over root 5. Now what we can do is we will have to convert this 10 inverse of half to cos inverse of 2 over root 5. For that, what I will do is I will use a substitution method. So I will let theta be equal to 10 inverse of half. I am letting this 10 inverse of half as theta, and on applying 10 on both the sides you will get 10 theta equal to half. Let this be equation number 1, this be equation number 2. Now using equation number 2, I will draw the right angle triangle and let this be theta and let right angle triangle be ABC. And you know that the formula for tan theta is equal to opposite over adjacent. Now tan theta is equal to opposite over adjacent. Now opposite side value is 1 and adjacent is 2, so you level the right angle triangle 1, 2, and to get the value of AC, that is length of hypotenuse, what we can do is we can use Pythagorean theorem or Pythagoras theorem. So now Pythagoras theorem states that square of the longer side is equal to sum of the squares of other two sides. So now AC will be equal to now square root of 2 square plus 1 square, which will be equal to square root of 5. Now AC is equal to now root of 5. Now from this same diagram, that is right angle triangle, I would like to find out the value of cos theta. Cos theta now is equal to, now cos is adjacent over hypotenuse. Adjacent over hypotenuse. So adjacent is 2, hypotenuse is 5. Adjacent over hypotenuse 2 over root 5. Now applying cos inverse on both the side, you will get theta is equal to cos inverse of 2 over root 5. Let this be equation number 3. Now from equation number 1, theta is equal to 10 inverse of half. And that is the simplified form of 10 inverse of 1 over 4 plus 10 inverse of 2 over 9. And 10 inverse of half, I have used right angle triangle and converted to cos inverse, that is theta is also equal to cos inverse of 2 over root 5, which means 10 inverse of 1 over 4 plus 10 inverse of 2 over 9 is equal to 10 inverse of half, and that on further simplifying we get cos inverse of 2 over root 5. From equation number 3, 1 and 3, we can conclude that right hand side 10 inverse of 1 over 4, 10 inverse of 1 over 4 plus 10 inverse of 2 over 9 now is equal to cos inverse of 2 over root 5. Hence, left hand side value is also equal to cos inverse of 2 over root 5, and you know that right hand side is already cos inverse of 2 over root 5. Left hand side is equal to right hand side, that is 10 inverse of 1 over 4 plus 10 inverse of 2 over 9 is equal to cos inverse of 2 over root 5. Hence proved. Okay, let us prove using sine inverse property, the second question, sine inverse of 3 over 5 plus sine inverse of 5 over 13 is equal to sine inverse of 56 over 65. Again, I am going to take left-hand side of the equation, sine inverse of 3 over 5 plus sine inverse of 5 over 13. Now, before using the property, you will have to decide which property to be used. For that, again, you will have to look at the values of x and y. Now, here x is again 3 over 5, y value is equal to 5 over 13. 5 over 13. And here, to decide which property to be used, we will have to take the value of x and y. If x and y is greater than or equal to 0, and x square plus y square is less than or equal to 1, then we are going to use the first property, that is sine inverse of x plus sine inverse of y, which is equal to sine inverse of x times root of 1 minus y square plus y times square root of 1 minus x square. This is the property that we are going to use if it fulfills these two conditions. The two conditions are x and y should be greater than 0 or equal to 0, and sum of the square of these two values, x value and y value, should be less than or equal to 1. But if you check it for this question, x is greater than 0, y is also greater than 0. But if you find out the value of x square plus y square will be equal to 3 over 5 the whole square plus 5 over 13 the whole square. And if you find out the value for this, sum of the square of these two, x and y value, you will get this will be less than 1. If you simplify this, you will get less than 1, which means you can use this property, sine inverse of x plus sine inverse of y equal to sine inverse of x times square root of 1 minus y square plus y times square root of 1 minus x square. Now, taking left-hand side, I will substitute the values of x and y in this property and simplify. I will take left-hand side of the equation, sine inverse of 3 over 5 plus sine inverse of 5 over 13, which is equal to, now x is 3 over 5, sine inverse of 3 over 5 times square root of 1 minus y square is 1 minus the value of y here is 5 over 13 whole square plus y times what is the value of y? 5 over 13 times square root of 1 minus x square, 1 minus the value of x is 3 over 5 the whole square, close the bracket. Now, which is equal to sine inverse of, on simplifying this, 3 over 5 square root of 13 is 169 minus 525 is 144 divided by 169 plus 5 over 13 times square root of, again 339, 25 minus 9 is 16 divided by 525. On simplifying this, you will get these values, which is equal to, now sine inverse of 3 over 5 times square root of 144 is 12 divided by square root of 169 is 13 plus 5 over 13 times square root of 16, 4 divided by square root of 25 is 5, which is equal to sine inverse of 3 12 36 divided by 5 13 65 plus 20 over 13 5 65. And on simplifying this and taking LCM, sine inverse of, you get sine inverse of, we have LCM 65. On adding this, you will get 30 40 56 over 65. Now, which means sine inverse of 3 over 5 plus sine inverse of 5 over 13 is equal to sine inverse of 56 over 65. This is what we are asked to prove. Hence the proof, or hence proved. Now, let us solve for x, meaning we will determine the value of x. To determine the value of x, we will have to remove the other trigonometric functions. For that, so what I will do is I will use the substitution method here. I will let theta equal to sine inverse of x let this be equation number 2. And applying sine on both the sides, you will get sine theta is equal to x, equation number 3. If you remember, we have a square relation which says sine square theta plus cos square theta is equal to 1. I want to convert sine theta to cos, so I will make cos square theta the subject. I will remove sine square theta on the left hand side. So subtracting sine square theta on both the sides, you will get cos square theta equal to 1 minus sine square theta, and cos theta is equal to now square root of 1 minus sine square theta. And let this be equation number, let us say 4. Now you have sine theta which is equal to x from equation 3. Now substitute the sine theta equal to x in equation number 4. Cos theta will become cos theta is equal to now square root of 1 minus, what is sine theta value? X. So now sine square theta means x square, 1 minus x square. Let this be equation number 5. Okay, cos theta. Now from here again, if you look back, sine inverse of x we have substituted as theta. So now cos of sine inverse of x, in place of sine inverse of x you can substitute theta. So now equation number 1 will become cos theta which is equal to 1 over cos theta which is equal to 1 over 9. And from equation number 5, cos theta is equal to square root of 1 minus x square which is equal to 1 over 9. Now from here, what we will have to do is we will have to determine the value of x. To determine the value of x, we will have to remove the square root. So how do we remove the square root? So we will have to square both the sides of the equation. On squaring both the sides of the equation, this side square root will go off and you will get 1 minus x square. And when you square other side, right hand side, you get 1 square is 1 over 9 square is 81. So what I want is I want the value of x. So I will make x square the subject. And if I take x square other side, it will become easy for me, it becomes positive. So now I'll bring 1 over 81 this side. 1 minus 1 over 81 is equal to x square. Now taking LCM, 81 minus 1 divided by 81 which is equal to x square. And now you get 80 divided by 81 which is equal to x square. And what we will do is, on taking square root, x is equal to now square root of 80 divided by 81. So x is equal to now root of 80 divided by square root of 81 is 9. Now here you will have to further simplify root of 80. And if you simplify root of 80, if you simplify this square root of 80, you get plus or minus 4 times square root of 5 divided by 9. So now these are the two values of x. One x value is equal to positive 4 root 5 divided by 9. And another value of x is negative 4 root 5 divided by 9. These are the two values of x, which becomes a solution for this question. With this, I have come to the end of my lesson. And before I leave this platform, I have some assignment for you. First question is, prove that sine inverse of 56 divided by 65 minus sine inverse of 3 over 5 is equal to cos inverse of 12 over 13. Second question, prove that tan inverse of half plus tan inverse of 1 over 3 equal to tan inverse of pi over 3. And the last question for you, solve tan inverse of x plus 1 plus tan inverse of x minus 1 equal to tan inverse of 8 over 31. And for this question, you can identify the values of x and y and decide which property to be used. Check the conditions of the property and decide which property to be used, and try these 3 questions. Thank you so much for attending my lesson. See you in the next lesson.